Yeah. All right, guys. Good evening. Welcome back to our solid principles class. We were not able to complete it in the last class, right? So this today we'll try as much as possible to finish up with the remaining three principles. That's Liskov substitution principle, interface segregation principle, dependency inversion principle. In the last class, we talked about single responsibility and open closed, and I pushed the code to GitHub already as regards, what's the code we use majorly, right? I pushed that to GitHub already. And the rule for single responsibility states that a class should have only one reason to change, right? Meaning just one responsibility. And this is the example of a better way to write a code that has just one responsibility, right? And same thing with open close principle. So today we are going to be looking at three principles. That's Liskov substitution principle, interface segregation principle, and dependency inversion principle. Right. So starting with moment, trying to settle something. This segregation, Liskov substitution. All right, I try to plug my phone so my internet does not just go off to the blues. But anyways, guys, so today we're going to be talking about Liskov substitution, interface segregation, and dependency inversion. So yeah, this is what Liskov substitution principle. This states that object of a superclass should be replaceable with objects of its subclasses without affecting the correctness of the program. So object of a superclass should be replaceable with object of its subclasses without affecting the correctness of the program. So this is very, very straightforward, but I understand that the naming might be a bit confusing, right? And yeah, anyways, the principle is aimed at using inheritance correctly, and derived classes actually represent the specialization of what's or it actually represents what you specialized in the base class. So anyways, the reason for this is so that you have more intuitive and more consistent class hierarchies, right? But so I don't put too many gibberish in your head, right? I'll just go ahead as usual, drop an example. Let me be sure I'm recording. Yeah, all right, so drop an example, we look through it, tell us how it violates this principle, and then we try to look at how to fix it. So yeah, let's do that. So we are using smart home example, right? So we're using a smart home example. So let's try to write something, and so what's the name? It's called substitution principle. So we're using a smart home example. Let's create like an abstract class. I would explain what this does. So we have a smart home device abstract class, right? That other smart home devices can extend. So we have first function turn on. We have another function turn off, right? Because you want to turn off and turn on your smart home appliances or devices, right? And then we have another function connect to Wi-Fi. So this connect to Wi-Fi, yeah, it could be string network. And yeah, definitely you need a password. So this is a class, older smart home devices or appliances can, extend, right, or implement. So what we would do is we would create classes that actually implement this, right? So we have the very first class, smart TV. Say you have a smart TV for in your smart home application, right? It implements a smart home device. Create 3 missing overrides. The very first one connects to Wi-Fi. So as usual, we are not implementing anything. All we are just doing is printing. Maybe connecting smart TV to Wi-Fi network, and yeah, network. So we have this first one, smart TV to Wi-Fi network. We have the second one, turn off, right, which is just turning off smart TV. To be honest, the order of this thing feels weird. Anyways, turning off smart TV, and yeah, turning on smart TV. Okay, so we have this very first TV, right? Or this very first smart device. We can have another device. So let me think of something tricky. How about okay, yeah, could be an extension box. Okay, an extension box makes more sense. Class extension, smart extension box. Extension box, or is there any other thing? Yeah, extension box feels like the perfect example for this. So smart extension box implements smart home device, and yeah, create 3 missing overrides. So there's something happening here. Smart extension box doesn't support Wi-Fi connection, to be honest. Nope. So true. Unsupported error. So smart plug does not support Wi-Fi connection. Wait. Can anyone hear me though?
Yes, I hear you.
All right. So Wi-Fi connection. So smart plug does not support Wi-Fi connection. Turn off. Yeah, of course you can turn off smart plug and you can turn it on. I'll just go ahead and copy this. Copy turning off smart plug. Turning on smart plug. So turning on smart plug, right? So we have these 2 devices, smart extension box, smart TV. We can have like a simple function, right? A simple function that just uses this smart home device class. So something like a void setup device, right? Device, smart home device, and device. and then we can ask, yeah, so if you want to call like the setup device function, you need the Wi-Fi, right? Network and password, yeah. String network and password. String password. So because this is kind of like, an abstract class, whatever you pass in definitely will have a certain function. So you can just say device to turn on, and you can connect to network, right? Device dot connect to Wi-Fi. So we have this very, very interesting code, right? And it does something very, very simple. The code looks very, very nice, looks very, very fine. So let's go back to our rule. Objects of a superclass should be replaceable with objects of its subclasses without affecting the correctness of the program. So is there anyone that can kind of like just look through this code, tell me if it violates, and if it's perfect, then fine, you can also drop that, right? Before I talk about my own POV on this code, right? So if it's perfect, that's fine. If it's not, that's also fine. So you can, as usual, I'll just use the chat box, or just unmute your mic and let me hear what you have to say. Oh yeah, Samuel.
Okay, so according to this principle, the smart extension box would, or it is essentially you should not follow any principle, because it will throw an error whenever you're trying to connect to Wi-Fi. It's like, let's say think of an example that I use to like better express what I mean. Let's say we have a list of users, or we have a user class, and then we have different types of users. We have super admins, we have admin, and we have tenant. And anything that the user class itself are all going to be implementing the user class. That is, as a human, everybody can breathe, everybody can talk.
Yeah.
Like or yeah, not everybody can swim. And to be a human, all you need to do is just like if we are trying to let's say we have a place in our code that we want to use the smart extension box, and we are counting on the fact that smart home devices connect to Wi-Fi. It's going to throw an error, and it won't match up what that principle is.
Okay. Great. Is there anyone that has like a different perspective or view on this? Maybe, oh yeah. Is there anyone that has like a different perspective or view? So smart extension box is not following the principle because it will throw an error whenever they connect to Wi-Fi function is being called. So okay, fine. I totally agree with this, and this is kind of like the correct answer. Yeah, so okay, if this is the case, how do we fix this issue? Right? If this is the case, how do we sort this issue out? Any suggestion is fine. Like I mentioned in the last class, right? Being wrong just helps you understand better, right? So if you're wrong, that's fine. You'd not be criticized. We are like, I'm not sure anyone would criticize. I think this kind of like a place where this is kind of like where we're just here to learn and understand, what's going on, and help simplify. So you would see from the perspective of why you're wrong, or why you're right, or why you're correct, right? And right, I feel like that will help, right? Yeah. So that solution that you currently have in your mind might be the correct answer, to be honest. You just pick an idea. I think to be honest of the solution, we kind of like might have done something close in the previous principle, right? But anyways, just uh okay, multiple interfaces separating the specs. Smart extension can't implement smart device if it does not conform to the contract smart devices demand. Maybe make it connectable to Wi-Fi. Nah. So this, right? So take for instance now, um, we cannot force the client. It's just a way. Okay, let me use the example you gave, right, where you said, oh, humans can, you know, breathe, they can talk, they can do this, they can do that, right? But some humans cannot swim, and the thing is, you cannot, actually, force them to swim. That would always be a thing, right? Whether you like it or not, and that can be applied here. So we cannot just kind of like, force okay, because swimming is a thing. You have to know how to swim, right? That's kind of like, the example. So you cannot do that. Multiple interfaces separating the specs. How would you define that? So what do you mean by multiple interfaces separating the specs? Do you mean we have an interface to turn on, we have another interface to turn off, we have another interface to connect to Wi-Fi? If you can maybe just give me let me know what's
So since the implementations differ majorly by the Wi-Fi,
okay.
thinking that we have is to, since turning on and off, I want to believe it is something synonymous. We can't have a device that just turns on but doesn't turn off.
Yeah, definitely.
So that can be a single interface. Have another interface that handles the connection to Wi-Fi. So in that way, if we say that any device that can turn on and off is same for everything, so we won't have this kind of situation that we I don't know what to call it. I don't know what to call the interface, but we have the interface that implementation that doesn't support that, and then we have an interface that handles like so it is seamless throughout its child classes.
Okay, so let me start with implementing your thought process, which sounds like we're in the right path, right? So let's say abstract class. So abstract class, we can power on or power on device, right? So we can call this like a powerable device. Abstract. What the hell am I doing? Yeah, so we have to function turn on. I just copy this thing. We have to function turn on and turn off, right? And then we have another abstract class following what you said. Sounds, maybe we can name it, yeah, maybe a connectable device, or yeah, Wi-Fi connectable device, right? And we just come and then we pick this up. All right, so now that we have this, if we want to implement the smart TV, okay, we have a smart TV. Okay, we have a smart TV, right? So if we want to implement a smart TV, right? So it implements powerable device, right? But there's a problem with this, our new implementation. The smart TV also needs to connect to Wi-Fi. So how do we go about this?
believe that you can implement multiple interfaces. That was my thought process. So we are separating everything. Doesn't work in that sense.
Wi-Fi. Okay, so I buy this idea to an extent, right? And that is because it works. But there is something we might be missing from this implementation, right? So this works, this is fine. You can implement multiple interfaces, right? And just add them. But by default, right, our Wi-Fi connectable devices can turn on or turn off, right? So it will make more sense to extend it from here. It will make more sense to extend it from here and then allow smart TV. Allow smart TV to implement a Wi-Fi connectable device. And we still have our 3 missing overrides. And then for the smart extension box, so what would this smart extension box implement? Let me hear from you. I don't want to think about this myself. The smart extension box does not support Wi-Fi, so this should be straightforward. Okay, variable device, right? So smart extension box implements variable device, and we're fine, right? So we have our implementation. Command copy this, connect to Wi-Fi, right? So this turn off, turn on. That's for smart TV. Turn on, turn off. So off, and the smart extension box and smart extension box. So we have this, right? Is there anything I'm missing? So you can see we can always just implement variable device for devices that just want to turn on and turn off, and for devices that for devices that can support Wi-Fi, we just implement Wi-Fi connectable devices, right? So this way we are ensuring that we are following the rule, right? We are ensuring that we're following the rule. Smart home device. Oh yeah, so we switched it up. So we can just say Wi-Fi connectable device, right? So Wi-Fi connectable device. So we can just say Wi-Fi connectable device. What else again? Is there anything I'm missing? I feel like I'm missing something. There's something I want to say that I'm not saying. Something I want to say that I'm not saying. Anyways, if I remember. But yeah, so we have 2 different abstract, right? That that don't violate this rule of object of a superclass should be replaceable, because they are now different classes now. So yeah, power device is different, even though it's still a type of powerable device anyways. But yeah, you can now, you have your connect to Wi-Fi functionality, outside, and then they are kind of like independent and majorly right. The coupling, yeah, right, has been reduced, and then you can always reuse code. That's kind of like the benefit of something like this. Also better abstraction, as you can see, and this is way easier to maintain, right, than trying to like maybe manipulate or find a way around it, right? This is way easier to maintain when you kind of like separate dependence, right? And yeah, majorly that's just it for this. It's nothing complicated. Like I would always say, all these things are not complex. They are simple. I think it's just the naming that might just complicate it a bit. But anyways, give me a moment. Let me flow. Sure. All right. So the next one is interface. Oh, you can't hear much. I don't know if that's from me. I don't think it's from me though. So the next one is interface segregation. Um, yeah, okay, this should be easy. So interface segregation principle. So this one states that clients should not be forced to depend on method it does not use, right? Should not be forced to depend on methods it does not use. Okay. So let's abstract like a smart home application. Okay, so the next one is interface segregation principle. So that's, hope I got that spelling right. So we have an abstraction for abstract class, smart home app. So we have a few functions in this: void, turn on lights, and setting temperature. Say you want to set temperature, because of course your smart home app should be able to do this. Temperature, int temperature. And then we have another one, maybe play music, string song. And then we have another one, set alarm. Yeah, bedtime time. And then we have another one, maybe you want to activate security for some reasons. It's security. For activate security. Okay. So yeah, in some cases, right, there was a point where we used controllers. Is it here? Yeah, so where we have like a temperature controller, we have light controller and the likes like that. So let's say we want we want our controller that kind of like implements smart home application, right? We have a controller that implements smart home application. So The way to go about this is just, okay, we can have a complete smart home controller. Yeah, let me just write this: complete smart home controller that implements smart home app. Yeah, so we have 5 overriding like methods. So we can print activating security. Yeah, print activating security. What do you call this? Okay, activating security system. I feel like my examples are too straightforward. It's going to be much more easier to get it this way. Anyways, I might be wrong. Playing song. Print. Play song. Print set an alarm for time. This works. Then temperature. We don't have a degree Celsius. Print certain temperature. Temperature to temperature in Celsius. And then we have one more: turning on lights. Okay, so we have this complete smart home controller. Now I'm setting myself up. This is going to be way too simple. Okay, let's see. So class lights controller. So let's say we have a lights controller, or we can use, what was the controller we used here? We can use temperature controller. Well, let's use light controller. Implement smart home app, right? So we have activate security, not applicable. Oh, what's that? 15 more minutes. Play music. Your lights cannot play music, so not applicable. Set alarm. Your lights cannot set alarm, so not applicable. Why the hell am I not just copying this thing? And then we can print turning on lights. I don't like this example for anything. Turning on lights. All right, so yeah, let's take a look at this code. This code is too straightforward and I don't like it. But yes, let's take a look at this code and how it violates this, and how we can improve this or make this work. Yeah, it's too straightforward. You can just give an answer based on the previous examples we've had, right? Like, too straightforward. I'm not a fan of this. Yeah, who is answering? So how does this violate our principle? Clients should not be forced to depend on methods it does not use. So we have a light controller, we have a complete smart home application. How does it violate? Okay, I'll just give everyone like a minute. So this 2047. I'll check back 2048, and hopefully I know that there will be an answer already. It's not it's not like the most complicated principle we've looked at. It's kind of like most likely the simplest stuff. Okay, we just need to use the concept by creating different interfaces. I know you people have not answered my question. You are giving me solution without answering. What is violating here? We'll start with that, then we find solution. By creating different interfaces. You guys are not answering my question. I want an answer question like, hey, what exactly violates our principle here? So I'm sure that you guys even know what exactly is violating the principle. Then we can jump into solution. Hello, can anyone even hear me? Hello. I will not move forward if I don't get an answer. I'm not going to. What exactly in this is violating our principle? Client should not be forced to depend on method it does not use. We have the light controller, and then we have this.
Is it probably about security? Controller.
No, I just is it just the security? So okay, your answer says
Okay.
security in the light controller. In the light controller. Controller ID. Yeah, what do you say?
Basically everything apart from turning on the lights.
So everything in the light controller violates. So I think that's the only answer I've gotten. So that's a correct answer because I understand, right? But actually it is not the functions that are violating. It is the class. So the class is so I say client should not be first. The class is being forced to depend on method it does not use. So the light controller fully just violates the whole thing because what exactly is meant to be here? Right, nothing. What exactly is meant to be here? You don't know because lights cannot play music. Okay, fine. Now that we have this, how do we fix? So someone mentioned we just need to use the concept from. I don't know the concept from the previous principle by creating different interfaces. So a function is not forcing, is not being forced on a class implementing another. So how many? Okay, yeah, we understand that is interface. We need interfaces, right? But we need interfaces. But how many? Is it just one interface? Is it just one interface? I don't know. Is it just one interface or two interfaces, or maybe do we have to split everything into different interfaces, right?
So it's from the command abstract class. We see that these are very different functions per se. To be fair, we can actually split everything into yes.
All right. So abstract class. Abstract class. What should we call this one? Light control. We turn on lights. We turn off lights. So we have another one. Abstract class for temperature. Right. Just call it temperature control. I'm not wasting my brain here. Control. And yeah, set temperature is fine. I don't think there is anything extra. I have another abstract class that plays music, so it's going to be music control without breaking my brain. Control, and we have play music, and we can have another interesting function, stop music. Also, right? Do we need to pass song? Nope. Of course, if you're stopping a music, it is already playing. So, yeah. Then what else again? Alarm control. Abstract class, alarm control, and then set alarm. Just moving this here, and security control. Say abstract class, security control. Activate, deactivate security. What else again? I think that should be it. So we can just dispose. We can dispose this. We can dispose this. Okay, so for the light controller, we just implement the light control, and yeah, what exactly is going on? Oh, there's a turn off light function also. Then we can remove these useless functions that we have and have it here. So majorly, this is like the fix. This is like the fix to that. So we have a light controller. We can have a speaker that, you know, a speaker that implements. Trying to see. So does our speaker, does the speaker use alarm? I'm trying to look at a controller that can use two of these interfaces, right? So let's say our speaker, right? Okay, yeah, let's say it's a smart speaker that implements music control, right? And then also we can have alarm control, right? Maybe for turning on and turning off alarm, your speaker can have the functionality, and we can implement both, right? Yeah, we can implement both. So play music, turning off lights, turning on the LTI to here, turning on lights, play music, playing song. Stopping music, and we have this one, set alarm. So setting alarm for time. Yeah, so I believe this kind of like, you know, this kind of like tells, you know, or solves our initial problem of not forcing clients to depend on methods that they don't use. So it's like the simplest. I don't know which is simple, maybe single responsibility or this one, but based on the fact that you already had like the idea already, right? It has made this much more simpler. So what we did is we splitted the smart home application into different interfaces. So the interfaces are more focused, and each of these interfaces, they have much more specific capacity or capability. And yeah, classes can now implement interface when they need it. And we can, for the smart home controller, what we can do for the smart home controller is just implement everything. Smart home controller, we have the smart home controller then, right? So we can just implement everything: light control, temperature control, music control, alarm control, security control. So majorly we have all this, and you guys can do justice to the print statement. This looks a bit messed up. You can try to group it on your end through, but I don't think this can be grouped though. But anyways, yeah, you can add your print state. I mean, you know what, let me just do this so I'm sure this. So because I'm going to push this code, right? So activating security, deactivating security, playing song, playing song, frame, setting alarm for time, degree Celsius, whatever, setting temperature, right? Setting temperature to temperature in Celsius, and then frames, stopping music, turning on light and turning it off, frames, turning on lights, okay, it should be off, turning off lights. It seems like the call ended when trying to do things. Okay then. So we're done with interface segregation, right? Principle. So yeah. So this allows for much more flexibility, less coupling. So you can depend on only the interfaces you need, and new functionality can be added by creating new interfaces, right? So this makes your life easy. It also makes testing very, very easy, and the code also becomes much more readable, because I can tell that, oh yeah, this is an abstract class for music control, this is an abstract class for temperature control, rather than having everything in just one place. So this last principle is called dependency inversion. Okay, so we're trying to see how we can do this. Well, let's try. So let's first state the principle as usual. So this might be, this is kind of like two. Okay, let me just write this so you can understand. So we have dependency, inversion, principle.
Are you sharing your screen?
Oops. I thought I was sharing, but I wasn't. Okay, so yeah, this is what I have. So we have dependency, inversion, principle, right? We have, okay, so this is the interface segregation I was talking about. Yeah, so I'll push this code, so there's really nothing to worry about. It's not even anything serious, to be honest. So the first one is eye level models should not depend on low level models. What should depend on abstractions. What should depend on abstractions. Then the other one is abstractions should, are you updating? Should not depend on details. Details should depend on abstractions. So let's consider like an example. So I know this is something a lot of us do, right? So but you see it from a perspective very soon. So we have class. No, I've not even created this. So dependency, inversion, principle, redirect, and so we have a class smart lock, right? That does just two things, right? That does two things. So void lock and so you can lock and unlock door, and what we're doing is door locked and door unlocked, door unlocked. So we have another class security system, that has a function called harm system. Arm system, and what arm system does, it does two things. You lock. So what we can just do is just create a variable here, lock, equals smart lock, right? And so we lock dot lock. So it doesn't sound weird. So smart lock dot lock, just having this. Then we can print, oh yeah, we have the system. So security system armed. So we can also use this to disarm like a system. So let's say we have like a security system that has a functionality that allows you to arm a system and disarm a system, right? So we unlock system disarmed. Okay, security system disarmed. So we have a simple void main, does nothing than just find our security system equals to security system dot harm system security system dot disarm system. Okay, so um we have this we have this code, we have this nice code, right? So to be honest, looks fine. Looks fine. This is something that, on a normal day, this is how you implement a security system, right? But this comes with like its own version of problem, right? But I want us to look at this. This one I'll give you like a bit of time to study and understand. So there are two rules, right? High level models should not depend on low level models, both should depend on abstractions. Hmm. So look at this code very, very well. Then the other one, abstractions should not depend on details. Details should depend on abstractions, right? So we can look at this. So I'll give you guys like a minute, 2 minutes, 3 minutes. Look at this code. Tell me what's wrong in how it's, how it violates this rule. This is our final rule. So okay, I'll just give you hints. There's a coupling happening here. There's a coupling. There's a whole lot of things happening here. Jeffrey.
So, the smart security system is directly, um, it's basically working directly with implementation smart lock. And we shouldn't do that. So we should probably have it, create interface from it's a way by the person creating the object, and then the interface we can but the way it is now is just working with a single concrete implementation of smart lock. Something we can do is structure for the security system that takes in an interface of a smart lock and so what is that?
Okay, so it says our security system is working directly with the smart lock. Okay, 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 okay. Okay. That's one. That's one. There are a lot of things wrong. There are a lot of things wrong with this code, and I want you guys to view it and understand. I understand and just So this is to an extent focused on abstraction. Anyways, let me just, like I mentioned, I'll give you guys like enough time to just check this out, and how does it defeat, or how does it violate this rule. So I'll put the rule down here. Rule. How does it violate this rule? So yeah, this is all the code and this is the rule. Give me like moments. Oh wow, no response. Have you guys been able to look at this? Okay, Peter.
All right. So the rule says that higher level modules should not depend on low level modules. Yet both should depend on abstraction terms. What I'm saying is, like, the security system is depending on the smart lock to perform its own functions. So which breaks that. So what I feel we should do is we'll create another abstract class from which smart lock and security system will implement. And if smart lock want to perform its function in its constructor, it will take in the new abstract class. Yes, and we can pass. No. Like I say, I'm sorry. I'm saying rubbish.
Actually,
What I'm
you are getting it right. But please continue.
So what is very clear that the system is depending on which break that very first clear. As for the second one that says abstraction should not depend on the and that.
All right.
I'm done. No.
Okay, yeah. All right. So I kind of like knew this one would be tricky, and maybe that's the reason why they saved it for the last. But it's really not so tricky, right? So let's try to break what is breaking down. This is very, very obvious. This is it's breaking both rules, to be honest, right? So this is breaking both rules. So no matter how you want to look at it, because this number one, sorry, I already copied it here. High level models should not depend on low level models, blah blah blah. Both should depend on abstractions. Then the whole our abstraction should not depend on details. Details should depend on abstraction. Right. So yeah, how we can actually approach this one, because I'm trying to see how I can explain it, because I was hoping I was going to get multiple wrong answers, right? So that will help me, know where to come in with this explanation. Or does anyone want to give another answer, right? All right, so let's try to establish something. So security system is high level. High level. Smart lock is low level. So yeah, I'm trying to paint a picture for you guys. So we have a security system. Our security system is high level. High level models should not depend on low level models, right? Both should depend on abstraction. So meaning smart lock is low level, security system is high level. Smart lock in itself, it should depend on an abstraction. So let's establish that part, right? Smart lock in itself should depend on abstraction. Smart lock in itself should depend on abstraction. And then there's a second one, high level. That's our security system. Security system should also depend on abstraction. Another one is the second one is abstractions should depend on details, right? Abstraction should depend on details. Trying to see, I can picture this for you. So currently locking mechanism. You know what? Let's first try to fix this first one, and then we fix the second one. So smart lock is low level, right? In itself should depend on an abstraction, and security system should also depend on an abstraction. So if we look at this lock on lock, right, we notice that this is kind of like a locking mechanism, right? And the way we can do that is we first of all just abstract locking mechanism. Locking mechanism. Abstract locking mechanism, right? That just has like a void lock and unlock, void unlock. So the smart lock, right, has to implement our abstraction. So implement locking mechanism, and then we can override, right? So we have the overriding, so we can call this so now we are not just forcing an implementation, right? We're not just forcing an implementation. We can kind of like change what happens here, and we can also use another like class to implement locking mechanism. So let's say you have something else that locks, like your car, right? It's going to implement this locking mechanism, and then so let's say we have another lock that is biometric lock, right? Metric lock, that's a lock that uses fingerprints. So implement locking mechanism. We can have this. We can have this, and then say, oh yeah, biometric lock engaged. Awesome. Lock engaged. And also the other one is just simple as disengage. So we can easily just extend this locking mechanism. So the problem here is a security system just defines a variable smart lock, right? And this is not what we want, right? In our case, security system should also in itself depend on abstraction, meaning security system does not need to know the type of lock, right? So it can be biometric lock. The security system doesn't need to be aware of it. So the way to do that is we actually parse locking mechanism, and create a constructor. Just generate a constructor, and we have these. And so the security system is a system that doesn't need to know about the type of locking mechanism that is happening or whatever is going on. So easily when you're using the system, right, it's much more easier to just create a variable where you're using it and just inject it, right? That's DHI, that's dependency injection, right? But anyways, smart lock equals to smart lock, and then final security equals to security system, and just passing smart lock, which is a type of locking mechanism. So if you notice, our security system does not know what is being passed. It does not know it's smart lock that's being passed, right? And then we can decide to security dot harm system, and we find security dot disarm system and we find, right? Same applies to biolock. So we have biolock. So is it bio? Yeah, that was biometric now. Yeah, biolock. So biometric lock, and can call this one. We already called on security, biosecurity, security, and security system, biolock. Right. So biosecurity, dirt, system or the SAM system, the disarm system. So what we did is we introduced like a new abstraction called locking mechanism that defines, the interfaces for all locking devices. So any device that needs to lock, we defined, an interface. So our smart lock and biometric lock kind of like implements this interface, and security system also depends on, the interface, right, which is the abstraction, the locking mechanism, which is not a concrete implementation. So this would help you understand the abstraction should not depend on details, right? Details should depend on abstraction. So the details in this, our security system depends on the locking mechanism abstraction, meaning this is not a concrete implementation. It doesn't even know what is going on, right? It doesn't even know what is going on. So so we use dependency injection to, provide whatever specific mechanism that needs to be passed in, right, which in this case is smart lock and then biolock, right? And majorly that's what dependency inversion principle is all about. With this, you're very much flexible. You can have as many much lock that you want, and that creates reusability. And this is much more scalable than what we had before. I don't know if I complicated it or I made it much more simpler. I don't know, but yeah, does anyone have any question? I tried like to figure out like the simplest way to explain this, but this is only what's coming to my head. So yeah, does anyone have any question, or do you understand this dependency inversion principle? I need one feedback, either yes I understand or no, I don't understand. Where should I start from? Yeah, let me just get a feedback. No.
Yes. To an extent, I understand it because I mean, you can pass, for example, different kind of block to security system, and then you can make it available to your application. So yes, I do.
So you said to an extent. So from what extent don't you understand? Because I'm trying to make sure, because this is also like a recording, and I'm also trying to make sure, it's something you can come back to and then check it out, and also, remember, oh yes, this is the part I don't understand and it was explained, right? And majorly. So abstractions depending on abstractions, right? So majorly high level models should depend on low level models. Both should depend on abstraction, should not depend on low level models, right? So we established security system is a high level model because it is the model we are actually using on the high level, right? So more or less like a facade. Can I use the word facade? Yeah, a facade that hides other things, like under. Anyways, yeah, high level models should not depend on low level models, right? So they should both depend on an abstraction in which the abstraction is a locking mechanism, and the only time there is a concrete implementation involved should be when you are actually using it, right? So abstractions, this is more of everything depending on abstractions until you get to like the front of the code. But yeah, okay, you understand. Man, I don't know. So, anyways, we've talked about multiple, so the all the solid principles, right? Like, yeah, single responsibility, which has to do with keeping your classes focused and much more cohesive. We also talked about open closed, kind of like a design for extension without modification, right? And then Liskov substitution. Uh, this kind of like ensures subclasses can stand in for their base class, and interface segregation creates specific interfaces tailored to maybe clients or classes needs, right? And then dependency inversion depend more on abstraction than are not in concrete like implementation. I heard the sound now. Are not concretions. There was oh yeah, Augustine.
Okay.
I think the first one we spoke about smite is what I really don't get.
Oh, that's the
Uh,
score substitution thing.
yes, this course of I didn't really get it, but I think I understand the ISP. I mean, understand that. But then the this course one, I didn't really get it. I don't
Yeah,
really, really get it.
we talked about ISP, then we talked about Liskov substitution, interface segregation. Okay. Yeah. So we need to go back to the initial example that we had and then compare. So let me come back. Right. So the initial example we had was something like this. Okay, so let's go back to the notes that states the object of a superclass should be replaceable with object of its subclasses. Okay, is there a way I can get like my previous code? So let's go back. Control Z. Control Z.
Okay.
No, I'll come back. I know what.
I was thinking.
Okay,
Okay.
no, I know what I'm doing. I'll come back. I'll be back. So this is the code already. So copy and then go back. Okay, so this is the previous code we had, right? So we had this like code that is a smart home device that has like a function turn on. I just comments here. Maybe call it part code. So this separates it from the code. All right, so we have smart home device, right? Turn on, turn off. It does everything. Then we have a smart TV that implements smart home device because smart TV is a smart home device. But we have a smart extension box, right? There are two functions here. There is the first one, turn on. There's the second one, turn off, and then there's a third one, connect to Wi-Fi. The problem with this two function, right? The problem is, okay, don't let me highlight the problem yet. Let's go back. So if you see, if you look at the smart TV, you can connect to Wi-Fi, right, to your smart TV 100%, right? You can turn off, and then you can turn on. But the problem with something like this is for a smart extension box, right? I don't know, the extension box in the house does not connect to Wi-Fi. We cannot connect to Wi-Fi, right? But we can turn off and we can turn on. So by default, every smart home devices can be turned on or turned off, right? But it has been established that not all smart home devices can connect to Wi-Fi, right? So let's go back to the rule again. The rule says object of a superclass should be replaceable with object of its subclasses without affecting the correctness of its program. So if we come, where the hell is this? Good. Okay. So if we come here, if we're passing something, so let's say we have a void main here, void main, where we call setup device. Can we be sure that when, okay, so for instance, now we pass in a smart TV, right? Final smart TV, right, equals smart TV. So we pass in the smart TV, of course, right? Setup device. Smart TV. Oh, sorry, I was using the other one. I was surprised why it was not working. Yeah, so we can pass on a smart TV. We can pass in the network and password, right? And everything looks fine, right? So let's do something. Let's pass in the final what's the name of this smart extension box? Smart extension box. You know what? Let's run this code so that we can have like a visual overview of what I've been talking about. I was avoiding running code since, but it seems we might need to. So I'll comment this out. What's going on? Setup device. Something is wrong. Did I define a wrong? Oh yeah, most likely this is it. Okay, so I know I did not comment that properly. So let's try to run this code. So if we run this code, shoot. Terminal. That's I hope this one is called substitution principle. All right, so let's just clear this. So when we run this code, right, we have turning on smart TV and connecting to smart TV. But let's do something. Let's add our smart extension box. Equals to smart extension box, right? So when we set up device, and we pass in smart extension box, we pass in network, pass in password, and then we run this. When we're looking at this code, right, it looks fine. It looks fine from, yeah, but when you run this, you get an error. So it makes absolutely no sense for something that does not connect to Wi-Fi or something that does not support Wi-Fi to connect to implement it, right? So that is why we came up with this our solution where we separated it into parable device and then because all devices can be parable, but not all devices can connect to Wi-Fi. So what we did is we know that all Wi-Fi connectable devices are also parable device, right? So what we just did, we just extended the abstract class. So it's still the same thing as just having void in this, right? Because what we're doing is we're just extending it so we are not duplicating code, right? And then because all Wi-Fi connectable device can be parable, but not all Wi-Fi connectable, but not all parable device can be Wi-Fi connectable. So for the smart TV, what we did is we implemented the Wi-Fi connectable device, and for the smart extension box that does not need the Wi-Fi, we just implement parable device. And then when we call setup device, right, we can either passing Wi-Fi connectable device or parable device, but we already kind of like separated concerns, right? More or less like that. I don't know if you understand now, or there's still parts that I'm missing.
Yes, I do.
All right, great.
Good.
Oh, okay then. So I believe that should be it. The recording is not yet available, and that's because the video editor is working on it, right? So making it more professional for YouTube. But once it's done, I'll share the link for everyone to access it. I will also just push this code to GitHub, so you have like the updated like code, right? It's nothing serious, and that should be it for solid. And I just hope everyone understood. I know this dependency inversion principle might be tricky, but it's just simple. Just watch the videos like 3 more times, right? The video like 3 more times, or that section like 3 more times, you understand dependency inversion. Is not that complicated as it sounds, right? But yeah, it's just abstractions. It's just depending on abstraction until you are at the part where you actually use like the implementation. That's the simplest way I can explain it, right? I know that way I try to explain it might sound very complicated, but maybe over time we might just might implement something that uses a dependency inversion principle, and I'll just remind you, oh yeah, this is dependency inversion. But yeah, majorly I believe that's it from my end, and I don't think anyone has any question left. So thank you very much for joining. I don't know what the next class will be about. Wait, so you mean my laptop wasn't charging since? I don't know what the next class would be about, but whatever the class would be about would be communicated appropriately, and that should be it from my end.